Okay, so let's start with section 8.2. We do a bit more proportional reasoning here. Solving problems. Involving rates. When dealing with rates, it is often best to set up a proportion to solve a problem. Make sure that, all done, thank you. Sure that the units line up, right? Make sure that the units line up. In other words, if cans are in the numerator on the left of the equation, EQN, that means equation, you should also have them in the numerator on the right. So if cans are in the numerator on the left side of the equation, you should also have them in the numerator on the right side of the equation. Example, right? Let's say the problem says, hey, 2 cans cost, or 2 cans have a surface area of 315 square feet, let's say, super big cans, then you would expect, right? And then the question would say, hey, if you then had 5 cans, right? How much square footage are they expected, or what's the surface area that they would have, right? So it's kind of like, if this is true, this is a rate, you can kind of extrapolate, right, and predict what it's going to be for more or even less, right? So problems, right? I guess if you do have highlighters, right, we know that cans line up here, so you can't just all of a sudden decide to have cans and the denominator on the right hand side of that equation. You will have to convert units as needed. Okay, so if you have if you're working with problems and you notice, wait a minute, kilometers, miles, I can't work with this, I need to do some conversions, you go ahead and convert, right? Okay, so let's say first problem here, it costs $900 to fly a distance of 8,000 kilometers. Determine the cost to fly 350 miles. So in this case, right, you do want to make sure, right, you acknowledge, okay, this is a rate, so it costs $900 to fly 8,000 kilometers, right? And if this were true, right, then they're asking now if you travel the distance of 850 miles. So now we make sure we have the distances in the denominator, and we're wondering, right, how many dollars would that cost? Obviously, we have a problem, right? Kilometers and miles, right? So I will just make a note here. Different units, right? Therefore, convert. So you decide what you want to do. Go miles to kilometers, kilometers to miles. I'm going to convert 350 miles to kilometers. Miles cancel out. And I will not round. Okay. So it's 563.15. It just happens to be a finite decimal. So maybe I will have an arrow going out from here to there, saying that I'm converting, right? And then I'm going to set up my proportion again. Okay, proportion is just two fractions separated by the equal sign. And so I'm going to insert that conversion into this, and now I'm going to cross multiply and divide. Do you remember cross multiplying and dividing from IPR and so forth? So in a sense, what you need to do is multiply across like this. Okay, cross multiply and then divide. So this ends up being 900 times 563.15. And over here you have 8,000, right, multiplied by x, because you're multiplying x. That rings a bell, right? Cross multiplying. Okay, you cross multiply And what we want to do now is our ultimate goal is to isolate x. Okay, so we want to divide both sides by 8,000. And this cancels out like that. So you grab your calculator, and tomorrow I'll show you how to work with your new calculators. I just wanted to make sure I cover this part. So you get 63.35, and this should be in dollars, so we can round to 2 decimals here. No whole numbers. Always look at the context, right? 63.35. Right? And you can just write down here cost to fly 350 miles. So when do you want to use proportions? If they're giving you a rate, and based on that rate, they're giving you one piece and you need to find the other. Got it? That's how you know it's like, okay, this is proportional reasoning. Okay. The next question is going to use up more room than what I have down here, so I'm just going to start a new page. So if you don't have a whole lot of room left, I would say turn the page. I don't know where you're at, but okay. Question 2. Squirrel can run 32 meters in 65 seconds, while a pig can run 295 meters per minute. A, who is faster? By how much? And B, how long in minutes would it take for the squirrel to run 152 meters? So for A, when you're comparing two things, units have to be the same, and it's ideal to have the unit rate. Okay. Think of same units and the unit rate. Okay, those are the two things that I want you to make sure you do when you get a question like this. So split it up. Squirrel. They're both in meters, and time is going to be fairly easy to take care of. So I'm just going to make sure they're in unit rates, right? So it's 32 meters for 65 seconds. Divide both of them by 65, right? That's how you get the unit rate. So this is the rate. And And here you get your unit rate. 32 divided by 65, that's 0.492, which is 49 meters per second. Pig, you have 295 meters, and that takes 60 seconds, right? 1 minute, 60 seconds, right? So I won't even bother writing down 1 minute. It's already in the same units. So all I'm going to do is divide both of them by 60. So 295 divided by 60, that's 4.92 meters per second. And so this would be rate, and this is unit rate. Okay, so you have your rate, unit rate. So this is what we want to use. Okay, we want to use the unit rates for both of them. So we can clearly tell that the pig is faster. By, and we're going to do the math on the side here. And we get 4.42. No, sorry. Come on. 3, right? 12 minus 9, that's 3. 4.43 meters per second. So pig is faster by 4.43 meters per second. So that answers A. Now, I know this problem is probably a little simplistic, but watch out for, I could do one yards per hour and the other one, miles per hour or per second. Like, that doesn't matter. You know how to work with it, right? You know how to convert accordingly. I just want to make sure you get it to a unit rate before you get your final answer, okay? B, how long would it take for the squirrel to run 152 meters? Okay, so this is a classic, right? Use proportions or proportional reasoning, sometimes it's referred to, okay? So for the squirrel, we know, I'm going to go back to the original, 32 meters in 65 seconds. This is known to me, and now it's asking how long would it take to run a distance of 152 meters in X number of seconds. Okay. This is known, and they give you partial information, so you just have to extrapolate and figure that out. Okay. So we're just going to get our time in seconds and then worry about it being in minutes later on. So we cross multiply as always. So it's X times 32, and it's 65 times 152. So you're going to have two numbers multiplying and a variable with a number multiplying on the other side. Divide both sides by 32. And let's see what we get. 65 times 152 divided by 32. So that is 308.75. And what is this in seconds? Hold on a second, right? It's not quite, we're not quite there yet. We need it in minutes. So watch this. Nice and easy, right? 1 minute has 60 seconds. It's actually accurate to do this. So you cancel out the seconds. So you basically just divide that by 60, and that's 5.4145, and keeps going minutes. So we're just gonna say 5.15 minutes. If you wanted to convert that to seconds, that's fine, but it just wanted it in minutes. So that is my answer there. Okay. There's your homework booklet, page 1, bottom half. And I'm just gonna reiterate this, okay? You only learn math by doing math. You gotta make sure you watch out for whole units because number of coins, people, cans need to be rounded, okay? So we'll leave it at that.